Alright, silly people, here's the situation. We have a probability distribution, um, of which the physics doesn't really matter because this problem is just referencing an example that was done in the textbook. And we're meant to find the standard deviation of this probability distribution. And also in the example that this distribution was talked about, they already calculated the expectation value of x, which is h over 3. So we just have to calculate the expectation value of x squared, which will be the integral over all space of the x squared times the probability distribution over x. But the bounds of the problem are from 0 to h, so we're just doing x squared over 2 square root hx dx from 0 to h, which simplifies into integral from 0 to h of it's just x to the 3 halves over 2 root h dx, which evaluates to 0 to which evaluates to it's going to be 2 over 5 h 5 halves over 2 root h, right? The 5 will remain, the 2's get canceled out, so you'll have h squared over 5 for your expectation value squared. Okay. Then you just plug it into this standard deviation formula. So expectation value of x squared is h bar. It's just h squared over 5. And then this is going to be minus h squared over 9. So it's 9 minus 5 over 45 times h squared, which is 4h squared over 45. So the standard deviation is the square root of that, so it's 2h over the square root of 45. I just had to pick the least square rootable number. Okay, that's part 1 done. The next part is to find the probability that, given this distribution selected at random, would show a distance x more than 1 standard deviation away from the average. So the probability for the entire range is just 1, right? You're always going to find it within the range. So we just have to find the probability that it's 1 off, 1 standard deviation off, will be 1 minus the mean. It's the integral of the probability distribution from the mean minus the standard deviation to the mean plus the standard deviation over x. So you'll have 1 minus integral is already done for us. It was 1 over 2 root h 2/3 x 3 halves from mean minus sigma to mean plus sigma. Those 2's will cancel out, and then the mean plus or minus sigma will be h third plus or minus 2h over root 45. So you'll get 1 minus 1 over root h, 3 root h even, And then in here you'll have the square root of h over 3 plus 2h over root 45 to the third minus root h over 3 minus 2h over root 45 to the third, both under radicals. So I'm just going to distribute the 1 over square root h into this. Each of the cubic functions will all have coefficients in terms of h cubed. It's all under a square root. So it's going to be two things that have the square root of h squared. So it's just h. So you have 1 minus h over 3. And then I've factored out the h's, so it's just the same terms again. Which I'm not going to calculate analytically. I did just use a calculator to find the values of these things because it's a really gross terms. But it turns out that the value of those radicals is about 1/2. So your probability is about 1 minus h over 6. So there you go.